Module 2, we discussed two things. In Chapter 4, we discussed linear regressions, and in Chapter 5, it was all about probability. So let's just quickly review how we do the linear regression. So if we have a table of data, we can put that in the calculator. And I did record a video on how to do this in the other calculator, but most people would maybe be using a TI. So if you need to clear out your lists, you would go up to where L2 was highlighted, press clear, enter, and then you could type in your data. So we have the data for average delay in minutes for departures and arrivals of domestic flights at O'Hare Airport for selected years. So we're going to put in the data. I'm going to put in the departures as my L1. That means this is my X, and this is my Y. 56.7. And it does make sense that we would see if the delay in arrivals had anything to do with the delay in departures. See if they had a correlation or not. And to get a scatter plot, that's going to be a statistical plot, so stat plot. So I'm going to press, I need to make sure I don't have anything in here, so I cleared out Y1. I'm going to press second stat plot. I want to turn that on. So I'm going to press enter and turn it on. The very first option is for a scatter plot. It's going to use L1 for X, L2 for Y. That's all looking good. And then I'm going to press zoom stat. So I'm looking at that, the data, and it asks me, does the pattern look linear? It actually does. It does look linear. Nonlinear would mean it was looking more like a parabola or something like that. It says if it looks linear, estimate the correlation coefficient. Well, it looks positive, and I think it looks pretty strong. It's making a pretty strong line. It's not a perfect line. It's not a 1, but I would probably guess 0.7, 0.8, maybe 0.75. I'm just guesstimating. And when we run our linear regression, we're going to find out the actual values. So I'm going to press stat again, and this is a calculation. It's under linear regression. And I'm actually going to store my equation in Y1. To do that, I can press alpha trace and store it in Y1. So I have my equation. I'm going to go ahead and write it down here. Y equals, that would be A is 1.25 X. And then the B is my y-intercept, so minus 6.195. And it gives me R squared, and it gives me R. Now, R is the correlation coefficient. Ooh, boy, I underguesstimated it. It's 0.94. It's stronger than I guessed. This means this is a strong, positive correlation. Remember, if the number had been negative, it would be a negative correlation. The lower this number is, the weaker the correlation is. And we went ahead and wrote down the regression line. Interpret the slope, so 1.25. This means for each increase in X, so each increase in the delay of departure, the delay in arrivals, and it's positive, so it increases by 1.25 minutes. Interpret the y-intercept in the concept of the problem. So that would mean that if the departures have 0-minute delay, the arrivals are delayed by negative 6.195 minutes, which doesn't make sense, so this is not reasonable. You're not going to have a negative delay. Actually, that would mean it came in early. Okay, use the least squared regression line to predict the delay in arrival if the delay in departure were 58.5. So that's an x value of 58.5. So that would be plugging in 58.5 into that equation. So now that I have that line in y equals, and you could type it in yourself, it would also be on my graph. And if it's on my graph, I can actually hit trace and type in any, while I'm on trace, I have to be off of the plot and be on the y1. I can type in any x value I want, and it gives me the y value that goes with it. I could have also done 1.25 times 58.5 minus 6.195. and got 66.93. Now what if, okay, so they said the actual arrival time was 67.6. So what would be the residual? So the residual, let's remember how we found the residual. The residual is found by taking, let's remember, residual would be the observed minus the expected. In other words, this is the expected. The observed was what was actually seen here. So 67.6 minus the 66.93 would give me the residual. 67.6 minus 66.93, and we get 0.67, which would be above what's expected or above the average. Now it says to interpret the coefficient of determination. That's our r squared, and I forgot to write it down, so now I've got to go back in, run this again. R squared is 0.888888, so that's 0.89. This means that 89% of the variation of delays in arrival, is of the variation of the y's. So delays in arrivals is explained by the equation. It's always the variation of the y value. So this would always be whatever the y value is. All right, now let's review Chapter 5. Chapter 5. A fast food restaurant chain has 600 outlets in the U.S. The following table categorizes them by city, population size, and location. A restaurant is chosen at random from the 600 to test market a new menu. What is the probability that the restaurant is in the Northwest? It's the probability that's in the Northwest. So we would need to add up all of these that are in the Northwest. Well, that's 5 plus 30 plus 60, that's 95. So that's 95 out of the 600 total restaurants. What is the probability that the restaurant in the city is in a city over 500,000? Well, that's this line, so we need to add those all up. Oh, I'm going to grab my calculator. That's 150 oops, let me get my calculator in view. 150 plus 25 plus 30 plus 60. That's 265. Okay, so the probability of being over 500,000 would be 265 out of 600. The probability of being over 500,000 and in the Northwest, I'm going to put 500K, 500,000, and Northwest would be 500,000 and Northwest would be the 60 out of 600. 500,000 or in the Northwest. Okay, so there's a couple of ways you could do that. You could go in and add up all of these plus these two. So that'd really be like taking the 265 plus 30 plus 5. That would be 300 out of 600. Given that the restaurant is in a population over 500,000, what's the probability it's in the Northwest? So the probability it's in the Northwest, given that we already know that the population is over 500,000. Now remember, this one, we're narrowing down our table. So I'm only looking at this line. So Northwest would be the 60 out of only the 265. Given that the restaurant is in the Southwest, what's the probability that the population is under, and that should be, under 50,000. So under 50,000, given that it's in the Southwest. They're tricking us. So given that it's in the Southwest, we're going to have to add this column up. That would be 100 plus 15. That's 115. The number that's less than 50,000 is 15. So that's 15 out of 115. Given that the restaurant is located in a city with a population over 50,000, what is the probability that it's in the Northwest? This one's kind of tricky. Given that it's over 50,000. So that's combining those two rows. So I need to add up this row. Let's see, 100, 150, this would be 250. And Northwest would be these two. So that would be 30 plus 60, that's 90 out of over 50,000 would be this plus this. So 250 plus 265 would be 515. A jar of marbles contains 4 red, 3 blue, and 5 green. 2 marbles are drawn from the jar one at a time without replacing. What is the probability they are both green? So the first time I draw a marble, there are 5 green, and there are 12 total. When I reach in again, I've already gotten 1 green one, so there's 4 left, but there's only 11 marbles left in the jar. So that's 5 out of 12 times fraction 4 out of 11. That's 5 out of 33. What is the probability that the second is red given that the first is blue? Okay, so the first is blue. That'd be 3 out of 12. The second is red. That'd be 4 out of 11. That's easy. 3 times 4 is 12. That's 1 out of 11. What is the probability of drawing one of each color? Okay, so that one gets a little tricky because I could, I'm only drawing 2 marbles. So one option would be to have a red and then a blue, or a red and then a green, or I could have a blue first, then a red, or a blue, then a green. Or I could grab a green one first, then a red, or a green one first and then a blue. There are 6 different ways that could happen. So I have to find the probability of each of these and then add them all up. This one's really tricky. So red then blue, that would be 4 out of 12 times 3 out of 11. 4 out of 12, 5 out of 11. 3 out of 12, 4 out of 11. 3 out of 12, 5 out of 11. 5 out of 12, 4 out of 11. 5 out of 12, 3 out of 11. This one's a really tricky one. So I could find each of these probabilities. I kind of found that one earlier. That's 1 out of 11. This one would be 5 out of 33. 1 out of 11. 5 out of 44. And you could have put the whole thing in the calculator. I'm just being weird and doing them step. Oh, that's not right. I messed up there. That would be 5 out of 33 again. And then this one would be 5 out of 44 again. And if I added those all up, 1 out of 11 plus 5 out of 33 plus 1 out of 11 plus 5 out of 44 plus 5 out of 33 plus 5 out of 44. I ended up with 47 out of 66. What's the probability of drawing a red or a green? Ooh, so this is another one where we have to list out all the possible options. Okay, red or a green each time. So it could be a red and a red, or a red and a green, or a green, then a red, or a green, then a green, or a red and a blue, or a blue and a red, because it just said a red or a green, or a green and a blue, or a blue and a green. Did we cover all the different ways we could have a red or a green marble? I think so. Okay, so this would be 4 out of 12, 3 out of 11, because we took one red away. 4 out of 12, green, or 5 out of 11. 5 out of 12, 4 out of 11. 5 out of 12, 4 out of 11. 4 out of 12, there's 3 blues, so 3 out of 11. 3 out of 12, 4 out of 11. 5 out of 12, 3 out of 11. 3 out of 12. 5 out of 11, I apologize for that. I'm at the high school, and that was a bell. And then we would just add all of those up. For the sake of time, I'm going to move on because they're fixing to do announcements here. What is the probability of at least drawing one blue one? You would do the same exact thing, but with the blues. So at least one blue. That'd be a blue and a red, red and a blue. Blue and a green, or a green and a blue. Or two blues. So you'd have to find the probability of each one of those and then add them all up. That gets a little tricky. Hope this helps. If you do end up with any questions, you can always email me and I'll help out.